Hey, ladies and gentlemen, here we are with part two of transformations, okay? This is where it gets a little funky. Hopefully you watched the first one so you remember what it is I was comparing it to. I was comparing it to the quadratic function, right? Remember what your quadratic function looks like, folks, all right? Your original quadratic function looks like this. Y is equal to x squared, right? If you make a table of values, an x, y, you'll be able to plot up a bunch of points, 0, 0, 1, 1, 2, 4. Negative 1 squared is 1, negative 2 squared is positive 4 as well. Okay, so you have to remember what the original quadratic function looks like. Remember that we transformed it as well. This k at the end ended up moving it up or down, and the h in the middle here on the x moved it right or left, and then the a value here changed the shape. Okay, now the cool thing is that transformations work the same for every single function, regardless of which one it is. Now remember, we looked at these 6 functions in the last section. If I add 2 at the end of this, these original functions just go up 2, right? So let's look at these different types of functions. Now what we're going to do is we're going to look at any function. Y equals f of x being a function using x as a variable. And this represents any of these 6 functions, and not limited to these 6 functions, okay? There could be others as well. We are looking, first of all, at vertical translations. So vertical translations means that you're going to slide it vertically, either up or down, right? So up or down. So how this is going to look is now we have our original function and we go plus k. Okay? So if k is positive, it goes up. If k is negative, it goes down. That is a vertical translation. Next thing we're going to do, we're going to look at a horizontal translation, okay? Or a slide. That's what these are. So this k, oh, actually I'm going to call it k, I'm going to call it d. Sorry. Let's call it d. Okay? Now, why, if I'm going to use it horizontal translation, that means that I have to affect the x. So what we're looking at here is x minus c, okay? And we're going to look at what c value. If your c is positive, it goes right. If it's negative, it goes left. The next thing we look at is what we call a vertical stretch. Now this could be either an expansion or a compression, right? So let's see what a compression. So this is a let's say this is your parabola. If I stretch it vertically, what happens to it? It gets skinnier, right? If I compress it, what happens to it? It gets fatter, okay? So we can compress it horizontally. We can stretch it horizontally. We can compress it vertically. We can stretch it, we can stretch it vertically. So think of it as an elastic type of band, okay? So first of all, we're going to have a vertical stretch. And since it's a vertical stretch, you're affecting the y because that's vertical. So it needs to be on the outside of the x. So it looks something like this. Y is equal to a bracket f of x, right? And we're going to look at what happens if the a is positive, negative, whatever possibilities we have. And a horizontal stretch means that you have to affect the x directly. So what that's going to look like is, let's put the b on the inside, b of x. Okay? So you've multiplied the x value. What we're going to look at now quickly is just putting them all together. Okay, so here you have the original function, y equals f of x. If you do all of these things, if you do a vertical translation, a horizontal translation, a vertical stretch, and a horizontal stretch, this is what your final result will look like, with a, b, c, and d being numbers. Okay, they could be fractions, they could be decimals, they could be positive, they could be negative. All right. Now, what I'd like you to think about here, first of all, is what's on the outside here. The D and the A are on the outside, okay? That means that they affect the Y value. Plus D means you go up D units. Negative D means you go down D units, okay? A, if A is 2, it means you stretched it by a factor of 2. If A is a half, it means you shrunk it by a factor of 2. So look, you can stretch it vertically, or you can compress it. I lost it. You can compress it vertically. And look what happens to the graph, okay? One thing, oh yeah, so look, the A and the D affect the Y value, okay? So they affect the vertical stuff, okay? B and C affect the X value, so they move it left and right, and they stretch it horizontally, or they compress it horizontally. The A and the B also have one other thing, okay? And they deal with what we call reflections, okay? So if you want to flip it over the x-axis, meaning you want to flip it this way, so flip the parabola upside down, or flip this way, or flip the V upside down. What happens is that you're changing your Y value from positive to negative. So that should be on the outside of this. So you have a negative f of x. That means that all your values now become negative, which means it flips it over the x-axis. If you want to flip it over the y-axis, it means that you're flipping it this way, this way, this way, this way, this way, right? You're flipping it over the y-axis, which means that all your x values become negative. So it looks like this. You make all your x values negative, okay? So what we're going to look at now is a quick summary of all these different types of translations, and then maybe we'll look at a few examples, okay? So I gave you a quick rundown on this sheet here. Okay, this gave you a quick rundown. I'm going to break it down even further now. Let's look at it in a little bit more detail. Here's a summary. So if you change your y equals f of x into all these values, okay, your vertical translation, we can also think of it as a slide, right? If your d is greater than 0, it means that it just goes up d units, right? So your parabola here, if you wanted to go up 2 units, you just add 2 at the end. If you wanted to go down 3 units, you go subtract 3 at the end. Okay? That's the D value right here. We just did that one. If you look at the C value, it's a horizontal translation or a horizontal slide. If C is greater than 0, then it slides right C units. Now this one is a little bit trickier, okay? Because if I have f bracket x minus 2, compare that to x minus c. What do you think your c is in this case? Is it positive 2 or is it negative 2? This is the one that screws everybody up, okay? Is this a move to the right or is it a move to the left? Well, that depends. Do you think your c is greater than 0 or do you think it's less than 0? Look at what it is originally, right? X minus c. Hopefully you can see that your c is positive, so your c is 2, which means it goes right 2 units. Okay, if I have f of x plus 2, we'll compare that to f of x minus c. In order to get a plus here, it has to be x minus a minus 2, which means that your c is negative 2, and it goes left 2 units. All right, that's a little bit of a tricky one, but this is why we're giving you a summary, and we're going to do a lot of practice with it. All right? Okay, so if it's positive, it goes right C units. If it's negative, it goes left C units. And please write down these examples if you find this difficult, okay? These are the 2 examples that show you why and how it works going right or left, okay? It's kind of counterintuitive. Let's have a look at the next one. I'm going to jump to vertical stretches, okay? Now, again, vertical stretches are on the outside. So if you look at something like this, you go from y equals f of x to y equals 2 f of x. Okay, what's happened is that you've doubled your y values. You've doubled the value of the function. So if a is 2, for example, it stretches by 2. If a is a 3, it means it's stretched or expanded by a factor of 3. So if a is greater than 1, it's a vertical expansion by a factor of a. Like I was telling you, if it's 2 in the front, every y value gets doubled. If it's a 3, every y value gets tripled. You just double them, triple them, whatever that a value is, okay? Similarly, if it's less than 1 but greater than 0, still positive, okay? It's compressed by a factor of a. So if you have a half in front, y equals 1/2 f of x. That means that all your y values get halved. Okay, so it's compressed. It's gone down like this. It's compressed. As opposed to a stretch, okay? It's compressed. Now, the other thing that can happen here, what happens if your a value is negative? That means that all your y values go from being positive to being negative. That means that they flip over the x-axis, okay? So if your a value is negative, it flips over the x-axis. Now, what about a horizontal stretch, okay? A horizontal stretch, again, it can be a compression or an expansion. And this is where it gets a little bit weird again, okay? Because if you have, for example, y is equal to f of x, and we change that to y is equal to f of 2x, what happens is that you now, this is a little bit, it's opposite. Again, it's counterintuitive, okay? So in order to have the same thing, you've doubled your x. So to bring it back where it was, you actually have to take half of it. So these x's actually get half the size. If it's a 3 here, they become a third of what they were. If it's a 4 here, they become a quarter of what it was. So if your b is greater than 1, so 2, 3, 4, 5, 6, right? It's a horizontal compression. It's counterintuitive. It's not what you would expect. It's the opposite to what we have here, okay? So it's a horizontal compression of 1 over b. Similarly, if you have a fraction, so if your y equals f of x becomes y is equal to f of 1/2 x, okay? It means that all your x's now get doubled. Or if it's 1/3, they get tripled. This means you have a horizontal expansion of 1 over b. Counterintuitive, like I said, the opposite to the vertical stretch. We're just going to have to look at some examples before you get the hang of this, okay? And the last thing I want to look at is if you have b is less than 0. If you have a less than 0, what it means is that your x's now, this is positive x, this is negative x. It means that they flip over the y-axis. You have a reflection in the y-axis. Okay, so you've got 4 major translations or transformations that you can do here. This is your summary right here. Okay, all of these work in conjunction. They all work together. You're going to have situations where you need to do all of these together. That means that we're going to have an order in which to do them. This section right now, however, is going to keep it somewhat simple. Let me just leave that up there for a sec. What can I say? What else can I say? Okay, well, let's look at a couple of questions that you might get, all right? If I have now a situation where I give you a point on the graph of y equals f of x, a point at 3 and 2. So 1, 2, 3, 1, 2. There's my point, okay? Where is it going to be if you have negative f of x? So this is a reflection, but in what? What happens is that all these values become negative. So it means that your y values here become negative. So it means that it reflects down here, and the point now will be 3 and negative 2. Okay? If you flip it over the if you say negative x, well, negative x, your x is 3. Well, you just made it negative, so it's negative 3 and 2. So it's a reflection over the y-axis, okay? Boom. All right? Let's make it a little more complicated now. What happens with this right here? Well, what we're going to do first of all, let's see. Always deal with your expansions first, your stretches. Your vertical expansions, compressions, your horizontal compressions and expansions come first. Then come your translations and your reflections. Okay? So let's have a look. This one's on the outside. It is a vertical expansion by a factor of 2, which means that my 2 becomes 4. I'm now here. Okay? This now tells me that it goes right 3, so 1, 2, 3. This tells me it goes up 1. Boom. There's your new point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 6, 5 would be the location of your new point. How about this one here? Well, let's see. Let's start a new one. 3, 2, right there. This is working on the inside, on the X, so it's that counterintuitive thing, okay? It's horizontal, but is it a compression or is it an expansion? Hopefully you remember, looking at the summary here, if your B is greater than 1, it's a horizontal compression of 1 over B. It's actually 2, so it's a compression of a half. That means that my X values are half of what they were. This now tells me that it goes left 1. This tells me that it goes down 3. There's my new point at 1/2 and -1. Okay? The basic idea of transformations here, folks. And this is a point that's going to come up in the next couple sections as well. We always do our stretches before our slides. Maybe I'll just show you a quick example here again. How about if I gave you a graph that looked like this? Okay, here we go. This is y equals f of x. If I wanted to double this, if I wanted to say 2 of f of x, right? 2f of x, it means that all my y values get doubled. So this y value is 3, it goes to 6. This y value is 2, it goes to 4. This is 1, it goes to 2. You can see that what you've done is you've just pulled it out this way, right? Similarly, what could you think about what we could do here to make the same picture if we compressed it? Well, we can't really do that right now. Anyways, this is a lot of information, folks. I'd like you to try some of the questions in the book, okay, on this section, section 1.4. If you need some examples, look at the examples in the book as well. It should be pretty clear from what we've done here. On Monday, I'll be happy to tackle any questions that you have.